Good evening. Can you introduce yourself?
Yeah, yeah. So hi. So my name is Sahil Makandar, and I am currently working as the model lead AI/ML engineer and currently I having the 5.8 years of experience in the AI/ML field. So in my experience, I work on the computer vision and also the generative AI and optimizing the model, deploying the model on the edge, uh, and it's lots of the projects actually I work. So if I talk about the projects, the types of the projects actually I work. So inside the computer vision, like I work on the object detection, object recognition, then semantic segmentation, uh, such kind of the things. And also I having the experience uh, inside the deploying the models on the edge by using the TF Lite or ONX, okay, or TBM framework, okay. And I need to talk about like the current projects also. Like what?
Uh, um, yeah, we can get to that. But can you start with your experience in generative AI field?
Yeah. So yeah. So inside the generative AI, like from last like when this technology actually came, from that time actually we are working on that. So from the 2021, like we are working on that. Okay. Uh, so in that, like specifically, if I talk uh, like all types of the model, like encoder only, encoder decoder only, and the decoder only LLM models I work. Also, I having the experience like working on the vision LLMs also, and for some of the clients also actually we created some of the use cases and deployed on their solution. Okay, so for example, if I say like actually we created.
Just a second. Work means what kind of work? Like, is it creating pipelines and running the existing models, or did you work on the architecture side of the models, or is it something other?
Yeah.
Can you elaborate a little bit more on that?
Yeah, yeah. So work in the sense like creating the pipeline also, and also with respect to the customer specific data, fine tuning the models also actually we worked. Uh, Along with that, we inside the developed our own generative AI framework, which is called as the GAD. So inside that, developing the model from the scratch. So that also means doing the unsupervised training, the supervised training, doing the RLHF. So like that work also actually we did. And along with that, means deploying the this GenAI models. So that also actually we did.
Okay, so creating pipelines in the sense showing it on the like visually putting it all together.
Yes,
In
yes.
the,
Yeah, yeah.
so all of that comes to the into the same pipeline, right?
Yeah, yeah. Like from the
And
fine.
yeah, and I also see that. Sorry for the but yeah, on this since we are on the same topic, I also see that you have worked on the uh, deep learning compiler stack as well. So the attach coming to the Gen AI, does that mean that you have worked on the enabling these AI models, like optimizing these AI models and enabling this KV cache and all of that on any particular device or hardware?
Yeah, yeah. So, on the NVIDIA Jetson Orion, actually, we deployed some of the models. Okay, so the currently whatever this CES conferences happened, so there also actually that what is got presented. So in that, like what we did, we having one use case with respect to the uh, inter uh, means whatever the in the driver is there. So driver monitoring use cases are there. So for that, we taken one vision LLM model, and that actually is it lava? Is it lava? No, it is means we tried the first lava, but it is not giving the real time performance. Okay. So for that, we taken the one image caption model, and it is we combined with the one LLM model. So there for the image captioning, we use the blip model. So the use case is like when the driver will start their journey. So whatever the whole journey is there for each means for each time frame, we are monitoring like what activity he is doing. And once that journey is finished, with the help of a llama 3.1 instruct model, we are creating their entire context, like what actually he did. So in that way, like we created the pipeline, and this both the models we optimized to the tensor RT, uh, and we deploy
So,
to the
what
next.
kind of optimizations did you know?
Yeah. So actually, in my experience, like I work on the means the most of the kind of the optimization. So the quantization I know. Also the pruning, distillation, and clustering. Like I know. So for the quantization, like the most of cases we used the TF light, and also for the tensor ID also used. Okay. And also from the TVM, the compiler framework is there. So from that also we did the quantizations and all. And for the pruning and whatever other clustering and pruning, that also it is come inside the TF light. And with the tensor, the NVIDIA Tau toolkit is there. So with that also we can able to perform this pruning and the quantize aware training and all. Uh, and for the distillation, like I didn't work, but I having the idea like how it worked, because this Llama 3.18 billion, it is actually distillated and tuned to the 1 billion model by using that technique.
Um, uh, okay. So, do you know about the internals of this TVM, how they quantize and prune the model?
Yeah. So, means if you can I tell you like how the optimize the TVM model? So there are the jump. Yeah. So there are the total 7 steps are there to optimize the model to the TVM compiler. So inside the first step, like we need to import the model in the whatever the our pre-trained like framework is there. For example, the PyTorch or or TensorFlow or MXNet or anything. Then in the inside the next step, like it will generate the relay. So inside that, whatever this means, it will convert uh, that the tensors to the higher level representations, and inside that, like the graph level optimizations actually it is happened, like means creating the subgraphs, eliminating the redundant nodes, that kind of the graph optimization levels actually it is happened. Then it is going to the T step which is called as the tensor expression. So inside that, whatever the sorry.
Yeah, please.
Yeah, so inside that, whatever the relay output is there, it will take and it will convert to the tensor expression. And inside that, the advanced level optimizations are have happen, like the low level loop optimizations, vectorization, parallelization, like that optimization actually is coupled. Then after that, it will go to the next step, like auto scheduler step. So whatever the subgraphs are created, which is represented by the tensor expression. So it by using, there are the two types of the methods are there for the auto scheduler. So one is the auto TVM, where actually we need to define the predefined flag, like which searching algorithm or which kind of scheduler actually we need to use. And another type is there auto scheduler. So in that, the algorithm itself decide like which one the best scheduler is there. So with that means in that step, like the next step is like TE plus auto scheduler. So inside that it will select whatever the best configuration and best scheduler. And the next step is TIR, which is the tensor intermediate representation, which is the low level representation of the code. Then after that, according to the whatever the target hardware architecture, like if you having the x86 or the ARM architecture, it will use the LLVM compiler to convert the code to the machine code. Or if you're having the NVIDIA based, then it is using LVCC compiler for that. So like that, the whole optimization process is there.
Okay. S-
So
You have experience in compiling this TVM to
yes,
seen experience in compiling this TVM on specific architectures and the other.
yeah. So in one of the project, like actually we work with ARM. Okay, so on that uh, means there is the some smart camera project is there. So inside that they having the two models, the YOLO V3 and the tiny YOLO V3. And means we tried the other models also, but this models actually it is giving the good performance. So so that model actually we compiled to the TVM, and uh, we deployed to the IMX 93 and rock chip board on that process, on that hardware.
And okay, when what happens when any operator is not supported on that particular hardware? How do you handle that case?
Yeah. So this kind of problem actually means I faced the lot many times. Okay. So if means if that particular operator is not supporting on that particular suppose if you are running the model on the GPU, so it will fall back to the CPU. Okay, so inside the TF light actually we need to mention uh, uh, means uh, one uh, we need to mention that thing. So when actually we are doing the full integer quantization, so there is the one another option is there, like integer 8 quantization with float fallback. So if any of the operation is not supporting, then it will be fallback to the CPU. Okay. But when actually we are deploying the model to the Qualcomm kind of the platform by using the SNP or the QNN, so at that time, like we need to, if the operation is not supporting, we need to write the user defined UDO operations there. Okay. Uh, or else like suppose if we are working on the some kind of the object detection, and in the most of cases so there is the this dynamic size issue was there inside the NMS layer. So such kind of the layer we can remove, and we can write the scratch Python or the C++ code instead of that by removing that layer. Means by seeing the by analyzing the neutron app, we can able to see like at the which layer is supporting or not supporting by looking the logs and all.
Mm, okay. So can you explain a little bit on this robotics lecture that you have worked on the software stack for robotics?
Yeah. So for the robotics, like we use this ROS2, okay, where the publisher and subscriber kind of the nodes actually we use in order to communicate or to send the particular command. Okay. So apart from that, like creating the nodes and all that we can able to do. But apart from that, the most of time actually I work like deploying the models on the RD5 or the other robotic platforms are there. So on that, actually I work like optimizing the models for that, and deploying the models on that, and on and the writing the like that ROS nodes. So for that actually I work on that.
Okay, and what is the software stack that you use when you try to fine tuning LLMs? Is that any open source code you use
Yeah, for the fine tuning, uh, optimizing or fine tuning.
for fine tuning LLMs?
Yeah, so in the most of cases, this Hugging Face is already giving the predefined APIs, so that are there. And for the open source things are also there. And as I said, like inside our GAN platform, so we given both the options, like using the open source or using the Hugging Face related things, and also uh, yeah, like that one.
Mm.
So for
Okay, so is where you use those pipeline and fine tune the LLMs like based on the specific data set and all. Right?
yeah, yeah.
S- And do you also have an experience on quantization of the models?
Yes, yes, yeah. So uh,
Okay, specifically I'm asking about the LLMs, quantization of LLMs.
yeah, yeah, like inside the TRT LLM framework, so there are the options so to quantize the model to the intake.
What kind of
Sorry,
I didn't get the last sentence that you mentioned.
there is the one framework is there, TRT LLM, in order to quantize the model for the Jetson, sorry, for the NVIDIA AI platforms. So that I used. Okay. So inside the Hugging Face also we having the APIs calls. So that also we can able to get converting the model to the ONX, and from ONX also we can able to quantize the models. And also from the T applied also we can able to quantize.
Okay, but quantization. So how many bits? What is the quantization scheme that you mentioned during this?
Yeah. So inside the quantization, like whatever our 32-bit model is there, so we are converting this model to the FE16, like or the int 8 means 8-bit. So inside the TF, like there are the three types of the quantizations are there. So first is the dynamic range quantization, in which the weights are only the statically be quantized, and whatever the activations are there, it will get quantized at the runtime. Okay, so this actually we can able to run on the CPU only. Then after that, there is the full integer quantizations are there. So inside that, weight and activations are quantized at the conversion time only, at the quantization time only. So for that, actually, we need to use the calibration data and all. And the another quantization type, like as I said, like int 8 with the floats 16 fallback, and the float 16 quantization is also be there. So the basic idea of the quantization, uh, like there are the two things actually it is fine. One is the scale, and one is the 0 point. So the scale we can able means it can able to find with respect to whatever the max float value minus mean float value divided by whatever the max quantization range minus mean quantization range. So if you are using the intent quantization, so the max and mean quantization range is the 128 minus 127. So in that way, it will find out the scale. and the 0 point is nothing but like inside the float value, what is the value of the 0 is mapped to the quantized integer value. So it get find out by the round of 0 minus float mean divided by scale. So once we get this float and sorry scale and the round value 0 point value, then we can quantize the number by the round of whatever the weight is there, weight divided by scale plus 0 point. So in that way, like, we can able to do the quantization. So this is the basic quantizations technique, actually it is there. But
So if going back to the TBM, do you have any experience working on code generation?
yes, yes.
So given a, say for example, given a ONNX operator, let's take slice operator for example.
So code generation, in the sense the LLM based code generation, or
Yes. Yes.
yeah, not a machine code.
So even TVM has that based on the LLMs, right? Some operators it generates code on the fly given any ONNX operator or any particular say for example we want con 2D. So do you have any idea about that? Any knowledge or experience in that field?
Uh, you are talking about the semantic kernel concept, or
Yeah, it automatically generates the intrinsics based on the hardware architecture that I provide.
yeah, yeah. So yeah,
Say for example, it's a X280. If I give X280 architecture and I want Con2D, it generates the Con2D in kernel. Basically, it writes the kernel using those intrinsics and give it.
yeah. Means I know about that concept. Okay. So but with respect to the code generation, actually we didn't implemented this thing. So the same idea actually we adopted for one of the automotive use case, like the inside use case. So where we are taking the driver inputs, like what is the car health, or what is the tire health, okay, or such kind of the driver inputs actually we will take, and without uh, generating any code, we are like kind of the calling that particular function with the uh, model. So okay, so that actually we used so it is concept, it is called as semantic kernel. uh, mm.
Okay.
So that particular demo also actually be presented at this Bharat Mobility Expo.
Okay. So, which language do you prefer for coding data structures or Sahel?
C++ and Python. For the data structure, I prefer C++. For this, most of the coding, I prefer Python.
Okay. So, can you please share your screen and open any editor of your choice?
Yeah. Is my screen is visible?
Yeah.
Which hello?
Yeah. Yes, I'll just give me a second. I have shared it in the chat. And the question was, s- s- so you are given a linked list with the integer data for each of the node. You need to write the merge sort function on top of that for that linked list, and it should be in place, so you don't need to return anything. In place means? In place means you need to modify the same link of this. You just shouldn't create a new linked list and return that.
Okay. I need to write the whole code from the main and all the things, or just from.
You don't need to write the whole code. Just the implementing that function is good at. The word song.
My typing speed is a little bit slow. Sorry for that. Mm.
Yeah, Sumit.
Yeah, I think I'm completed.
Okay. Can you explain? Can you walk through?
Yeah, yeah. So inside the merge sort, uh, the logic actually are used with the recursion. Actually, we can able to uh, create the merge sort. Okay. So inside that means from the main, I will pass the head of the list. Okay. Then the upper bond. Okay, means it is the zero, and the lower upper bond means it is the whatever the n number of nodes inside that particular list, and the lower bound is the 0 1. Okay, so then I will take the head pointer. Then after that, if means this actually I need to do until the lower bound less than equal to upper bound, because inside the merge sort, like first it will means it will first all the uh, so what we can say this separating the arrays inside dividing from the mid, like it will do until there will be the one element inside the each of that particular individual array. So it will do up to that lower bound less than equal to upper bound. So for that, first we need to compute the mid, and mid is computed by the upper bound plus lower bound divided by 2. Then after that, we need to call again the recursively this merge sort only. So for now, we need to call it from the HPATR LB to mid, means from the lower bound to the mid of that particular array. And again, we need to call the same merge sort up to the HPATR mid plus 1. So this lower bound now become the mid plus 1, and the upper bound it is as it is. So it will divide until there is the only one element left into that array. Then once that did, it will parallelly start the merging also. So for this merging, like here actually we need to pass this that head pointer upper bound middle mid and the lower bound. Then it will call this particular merge function. So inside that these parameters will be there. Okay, so here I will means here actually we are dealing with the linked list. So uh, means I kept one temporary list which is with that, like we can proceed the jth elements. So temp j list I taken. Then the I is equal to a lower bound will be there. Then the j is equal to upper bound, and this is the l is equal to 0. So it is the temporary variable. So here means first we need to calculate the list of lengths also. Actually we need, because we need uh, like means up to that particular jth index, actually we need to go there. Okay, so inside the array we can directly index through the j, but because of this is the linked list, so so up to the jth index we can go like this, like temp j list is equal to temp j list next until the j is not satisfied. Okay, then after that, here actually I created one temporary array. Inside the number of the elements of array is equal to the whatever the length of this particular list. Okay, so for that I this length list function will give the that how many nodes inside that list. Okay, then after that this merge sort logic I apply, where if I less than equal to mid up to that means here actually we need to imagine like there are the two pieces of that array, and one piece we need to compare it to the one piece of element we need to compare to the another piece of the elements. So wherever we found that less comparison, so HPATR it is indicating by I, and temp j list it is indicating by j. So so if the HPATR data less than equal to temp j list data, then we need to store that data inside the temporary array, and we need to increase the x plus plus x index. We need to increase the I index, and along with that the HPATR index also we need to increase. Then in the same way the another else condition, like if that piece of element is greater than the first piece, so we need to save the jth data inside the k of x, then x plus plus j plus plus, and we need to do the means next element of the node also we need to take. Okay, so this will happen until one of this condition is going to be false. Okay, so in the some of the cases, like if the two pieces of that list is not the equal size, so that scenario also we need to check. So if the first piece of the array is greater than the second list of the array, so with this, if I greater than equal to mid, and if the still jth elements are remaining, so that jth elements also we need to take like this only. Then inside the else case, like if the in from the first array, if some elements are remaining, so that also we need to place. And finally, whatever the temporary array which we created, we copied to the main list. So that is actually I reimagined with the array implementation.
Um, maybe. Yes, I liking that's all from my side. Do you have any questions?
Uh, like is may I know like which kind of the role will be there if I got selected?
So on a high level, it's a AI compiler s- stack. Did you get a chance to go through the job description,
Uh, Computer
software?
vision. I heard.
Yeah, it's a software engineering AI stack. Basically, it means on a high level, we try to compile and optimize the machine learning models. So by the optimization here, we mean graph level optimizations and quantization and scheduling each of the node on the particular hardware, on hardware basically. So how do we schedule and all of that goes into the basically the compilation of the model.
Oh, okay.
So and there are sub teams inside for this. Like we do have a separate team for the compiler, a separate team for the runtime. Runtime in the sense the actual uh, stack where we can communicate with the device to load the model or run inferences. So the drivers and all of that comes under the runtime stack, and we have a kernel team as well to write the kernel level for our hardware. So all these are the sub teams under the basically the software team. So uh, yeah, it will be decided based on the interview and on a interview. So basically, our HR and manager will decide which sub team anyone will be part of. But it's not that you will have to work only with that particular thing. It's more flexible, I would say. Say if you are interested in any task which other team is doing, you are more than welcome to contribute there as well. So yeah, it works.
Mm. One more question I have. Sorry for
Yeah,
yeah. So how like about like work life balance was there in that?
work-life balance, I would say it's pretty good compared to other startups scenario, but that doesn't mean that it's I would say it's not like a 9 to 5 job or 10 to 5 job. So you're whenever the based on the priorities and the assigned task, right? You might have to sometimes work late or work in the odd timings as well, but it also means that you will get a chance to take off when needed, and yeah. So it basically depends on the amount of work that we have.
Yeah. Go. Yeah. Actually, that really I having questions. Yeah.
Oh, yeah, it was nice talking to you. So I'll, yeah,
Thank.
thank you.
Yeah. Thank you so much.